Electricity is all around you. When you turn on a light bulb, heat up your mac and cheese, or stream your favorite movies. To power our electronic devices, energy must be moved from where it's generated, like at a power plant or a wind farm, to your home. Have you ever stopped to think about how that happens? Electricity flows across our country along a giant web of power lines called the electrical grid. This grid is connected and controlled by substations, like the one I'm standing in right now. I'm Jack, and today we're at my hometown of Hays, Kansas to meet a relay technician, someone who plays an important part in making sure electricity is safely transported around our world. I hope what we learn isn't too shocking. Come on, let's go. I'd like you all to meet Nolan, a relay technician at Midwest Energy. Thanks for letting us come out to your shop to learn more about what you do.
Absolutely. I'm excited to show you what I do behind the scenes.
Me too, and I'm familiar with relays already.
Really?
Yeah, I'm on the 4x100 meter relay team at school. We're pretty fast.
Sorry to pull the plug, but the relays I'm talking about aren't quite the same thing. We don't pass batons, but speed does play an important role. The electrical grid is a giant connected system that moves electricity from where it was generated to anywhere that needs to use it, like your home or school. It's one of the most amazing feats in human engineering. We can break the grid down to three parts: generation, where the power is made; transmission, how it is moved across the planet; and distribution, how it is delivered. A relay technician works on all three parts. Think of our electrical grid like a flowing river. At certain points along the river, we have built control points that work like dams to control how fast the water moves through it, how much water flows through, and where the water will go next. Those control points are called substations.
Okay, that makes sense. Electricity flows along those big power lines I see on the side of the road when I travel to my track meets. But what does a relay have to do with it?
Great question. You've probably been curious about this contraption. This is a relay. Relays are super important inventions that help keep the electrical grid safe. These smart devices detect anything that disrupts the grid and will instantaneously tell circuit breakers to shut off the damaged sections to isolate the problem. These disruptions are called faults. This process protects the overall grid and limits the number of customers who may lose power.
What would cause a fault in the first place?
Storms are the most common, but you might be surprised at some of the culprits. Squirrels can be a huge problem.
Squirrels? That's nuts.
Let's just say squirrels are good at getting into dangerous places.
So you could call them KFS?
KFS?
Kansas Fried Squirrel.
Right. Let's get back on track. So my job revolves around the programming, installation, repair, and maintenance of these devices. Some of this work is done in a warehouse like this one to program and test the relays. Before installing, we need to know the relays are functioning properly. That means we make sure they shut off the correct breakers and they do it at the proper speed, which is what your relay team and my relays have in common. Relays need to detect faults super quickly to protect problems from magnifying and shutting down large sections of the grid. The second part of the installation process occurs out in the field. Relay technicians install the programmed relays at new substations, conduct maintenance on relays, or even replace older devices. I continuously test the relays around Hays to make sure they are operating correctly. When they aren't, I make repairs and reprogram them.
Can you show me more about how relays work?
Sure, I have a pre-programmed relay device behind you. Would you like to help me test to ensure it's working properly?
For sure. Nolan showed me an old mechanical relay, which has now been replaced by a computerized relay. He explained that relays work like a breaker in our homes. They shut down the power when something out of the ordinary happens in order to protect the whole system. This is important to protect the equipment so it can be easily fixed, reducing how long the power is out.
This has the ability to make smart decisions where your home breaker does not. We have this breaker is closed. What I'd like for you to do is open that breaker with this trip button here, and we will see the lights go out much like at your house. Okay,
When the light turns off, is that like your power going out?
That is correct. That would be no different than something happening out at the line. The light bulb here is representing that there is no power or service to your house. If we didn't have these protective devices, ultimately, the lines would burn down, transformers would blow up. Our sole purpose is to provide reliability and safe energy. And that's all there is to it. Do you want to see what these devices look like at a substation?
That would be awesome.
Come on.
We went to a substation and saw live relays working in the field. Nolan told me about how there are multiple relays that work as a redundancy in case any equipment isn't working correctly. They showed me a massive bank of batteries that can power the substation for days if there is an outage. There are so many wires going in and out of the substation, and each has an important job to do.
Now that you have a basic overview of how relays work, only 4,999 hours until you become a certified journeyman.
What? What do you mean? 4,999 hours? That's over 200 days.
8 hours a day, that's roughly 2 to 3 years of work. We let you sleep, and you still get to see family and friends now and then. While 2 to 3 years might seem like a long time, there's a lot to learn to become a relay tech and know how to deal with serious voltage in a safe and efficient manner. Midwest Energy and many other energy companies offer what is called a registered apprenticeship program. As an apprentice, you'll get paid to learn everything you need to know about how to do this work safely from an experienced relay tech like me. You'll spend about 5,000 hours getting paid to take online training courses, job shadow experienced technicians, and gain hands-on experience in the different parts of this job. It may seem like a lot, but it is electricity after all. Not something you want to shortcut. There's an element of danger in this work if you don't follow protocols, and no one wants that. If you learn best by doing, this might be a good option for you. At the end of the registered apprenticeship, you'll take tests to prove your expertise. If you pass, you'll receive certifications that qualify you to be a technician for any energy company in the nation.
Is that how you got started in this industry? Through an apprenticeship?
Sort of. After high school, I attended Fort Hays State University and got a major in business. After I graduated, I knew Midwest Energy was a great company to work for, but I knew next to nothing about electricity. Midwest Energy hired me for an office job. In that role, I started learning more about the energy industry. Energy offers so many different types of careers. Some are obvious, like a lineman or plant manager, but there are also lots of engineering roles and business-related jobs. After a few years, I wanted a job that would allow me to work outside, so they offered to pay me to go through the training to become a relay technician. And now, 6 years later, I've achieved journeyman status, which means I'm a fully qualified relay technician who can train others to do this trade. I'm so glad I made the switch. I am paid a great salary with lots of potential to grow into different jobs over the course of my career. Energy is an amazing industry to work in, and it's one that's only expected to grow in the coming years as AI and advanced manufacturing dramatically increase our nation's demand for power.
Nolan, I can tell you enjoy working in energy. Your enthusiasm is contagious. I can 100% see myself working in a career like this someday. Do you have any suggestions about what I can do right now as a student to help prepare myself for a career like yours?
Math. Most people think they'll never use it. I can say I use the Pythagorean theorem on a daily basis. Trigonometry, algebra, geometry, and arithmetic are all super important in my work. Other courses you should consider taking are science classes like chemistry and physics. Learning watts, volts, and amps. Having a good background in these fields will be helpful. Computer programming is vital to my job. I'm constantly using a computer to program and test the relay devices, so I would consider taking a few programming electives too. Lastly, I suggest you explore some of the hands-on career and technical education courses your school offers, like industrial technology. Knowing the basics of using tools will help you later as you learn to install and repair electrical equipment.
Thanks so much for showing me what you do and giving me a tour of the substation. I never knew how incredible our electrical grid was. Now when I turn on my TV or heat up my mac and cheese, I'll know how the power got to my house. Plus, I'll never confuse your type of relay with a track event again.
How about instead of passing on a baton, you pass this information to your relay team?
Now that's a relay I can handle. Thanks, Nolan, and everyone else at Midwest Energy for giving me a behind-the-scenes glimpse of how energy jobs power the world. I hope you found it electrifying. Learn more about this and other high-demand careers at HirePaths.com. Until next time, this is Jack signing off in Hays, Kansas for Cool Careers. Have a great day.
Good.
Don't worry, it's just chicken.